Hi guys, welcome. I'm going to be quickly going over this classic problem of I have a square, I've got a circle inside of it. How do I find the area of the error? And by error, I'm referring to these four shaded, unshaded regions right here in the corners. And the classic approach to that is if I take the area of a square minus the area of a circle, I get the error. And again, error is those four corners that I was pointing to earlier. Well, what's the area of the square? Well, let's say this length is A right here. If this length is A, then this length is also A. Why is that? Because it's a square, and by definition all the sides are the same. How do you find the area of a square? Well, we do A times A, which is where we get A squared, minus the area of a circle, pi r squared. And then next I'm going to make this observation, r is equal to A over 2. That's actually not too hard to see. So as you can see here, this length is A, which also means this length is A. But this length I've just pointed to is the diameter of the circle. And if that's the diameter, radius is halfway by definition. And if r is halfway, that means r is halfway the distance of A, so like from here to here, and that distance is just A over 2, which is what I've done right here. If that did not make sense, I would encourage you to really make sure you understand that, because that's the hardest part. Once you get that ahead, the rest of it is really straightforward. I'm just going to plug in r. So let's go back to this top formula, which I'm pointing to right here. I'm going to plug in r as A over 2, which is what I've done right here. I then distribute the exponent. I get A squared over 2 squared, which gives me A squared over 4. A squared over 4 is the same thing as A squared times 1/4. I'm then going to factor out an A squared out of both of these terms right here. And when you do that correctly, you're going to get A squared times 1 minus pi over 4. And 1 minus pi over 4 simplifies roughly, if you use enough digits for pi, to 0.2146. And what is this saying? Well, it's saying if I know the area of a square, take roughly about a fifth, a little more than a fifth of it. That will give me the area of these unshaded regions that I'm pointing to right here. I hope you guys enjoyed this video. I hope it gave you maybe some more insight to these types of problems about taking the whole and taking away parts. That's it. See you.